But as you know, we can't just leave things nice and neat. There are some things that happen to make them not so nice and neat. So let's look at this one. Solve each system of equations by graphing. So if I graph y equals 2x plus 1, that would be this. Y equals 2x plus 1 will give us this line right here. Okay, that's what they show us. Now, y equals 2x minus 3 gives us this line right here. Notice what kind of lines these are? Parallel. What do you know about parallel lines? They will never cross. So tell me, how in the world could you ever have a solution to it if our solution is the point where they cross? And these two will never cross. So it is possible, if you have parallel lines, that you will have no solution because they will never cross. So if I say solve each system by graphing, I want you to graph each one of these and then tell me that there is no solution. No solution. Now, even if I didn't graph these, there should be something right here about this equation that jumps out at you. They are parallel, means they're the same distance apart, means they have to have the same slope. And they do. They both have a 2x. So anytime you see that they both have the same slope, it is going to be a no solution because they are parallel. Okay, let's look at the next one. Now, this one right here. So first of all, we have to put this second one in slope-intercept form, which means I would have to add 3 to both sides. Add 3 to both sides. So that would cancel. So on the left-hand side, I would just have a 1. Now on this side, I would have a 2x. And if I have a negative 2 and a positive 3, that would give me a positive 1. Now, here's the one that I just rearranged. Here's my original. What do you notice about those two? Exactly the same. So what do you think would happen if I graphed those? Well, if they're the same line, they're going to go right on top of each other. So if my solution is everywhere that they touch, and if it's one laying right on top of the other, they're going to touch at every single point. So that's where you have an infinite number of solutions, and that's what you would write. So if they're parallel, they will have no solution. There's no solution. But if they touch at every single point, there's an infinite number because, you know, lines go on in both directions forever. Both directions forever. So there is not a single number of solutions, an infinite number of solutions. So you could write no solution, or if it's in the case of 1, it's the same line right on top of it, infinite solutions. Okay, so no solution or infinite solutions. Okay, I want you to practice with D and E. Practice graphing both of those. Tell me how many solutions. Could have one if they cross at one point. No solution or infinitely many. Try those, please. All right, hopefully you're back with me here and we've got these two worked out, D and E. So I've went ahead and looked, and remember, if they're not in slope-intercept form, you have to put it that way. This one is fine. That one's fine. This one's not. So I took and I have to have y by itself, so I divided everything by 3. Everything. So this divided by 3 cancels. Now I've got 2/3 x, and then 15 divided by 3 is 5. Now I want you to look at this slope and this slope. So if you graph those, they are going to be what? Parallel. And if they are parallel, then they will never cross. So your answer to me, come on, no solution. No solution. Now, looking at this one, neither one of these are in slope-intercept form. So I took y equals x minus 2 plus 3 and just combined those right there and made it y equals x plus 1. This one, I just had to move the x over, so I added x to both sides. Y equals x plus 1. They are the same line. So if they are the same line, then they are going to be graphed one right onto, there's one. You would come back and graph the other one right on top of it. Infinite solutions. infinite solutions. So could have one if they were to both just graph like this, and you have one, that would be a one solution. If you end up having parallel lines, which means the slopes have to be same, that is a no solution. Or it could be, that's a U, that's an I. Or it could be that one is graphed right on top of the other, which is our infinitely many, infinite solutions. So this would be something that I would highly recommend you putting in your notebook. All right, one solution they would graph once, parallel no solution, one right on top of the other, infinitely many. Okay, good luck.